Hey Figs fam, welcome to season 3 of the Geo Show. Today we're going to talk about streams and floods. Thank you for being patient while I've been on a little bit of hiatus. I've been kind of working on the channel, and I hope you like what I have to offer. As you can see, I've gone with deciding to show my face and my office and look around. It's a lovely shade of green in here. I think it's nice. I've got some plants and some fish. Telescope, got some art wall things. All right, let's get going. First, shameless self-promotion. Special shout out to my patrons, A Friendly Doggo and Tyler Flo Robinson. Your continued support has kept my channel going for 2 years now, and I can't thank you enough. Head over to www.patreon.com/Feegs and sign up now. Even the lowest tier gets you exclusive Discord access at the Feegs Mothership and a shout out in every episode of the Geo Show, so I think that's pretty cool. And while you're at it, why don't you go and check out my Redbubble page where you can find cool Geo adjacent merch like Thug Rock stickers or International Rock Liquors t-shirts. Okay, now on to the show. Okay, so up first, we're going to talk about the hydrogeological cycle. Water is constantly on the move. It is evaporated from oceans, lakes, streams, the surface of land, plants through transpiration by solar energy. It is moved through the atmosphere by winds and condenses to form clouds, water droplets, or ice crystals. It comes back down as rain or snow and then flows through streams into lakes and eventually back into the oceans. Water on the surface and in streams and lakes infiltrates into the ground and becomes groundwater. Groundwater slowly moves through rock and superficial materials. Some groundwater even returns to the streams and lakes, and some goes directly back into the oceans. Its movement is powered by the sun and gravity. It's a non-stop, never-ending cycle that powers life and everything that we know. While it's moving around, water is stored in various reservoirs. The largest by far is the oceans. This accounts for 97% of the volume. Of course, that water is salty. The remaining 3% is fresh water. 2/3 of our fresh water is stored in ice, and 1/3 is stored in the ground. The remaining fresh water, about 0.03% of the total, is stored in lakes, streams, vegetation, and the atmosphere. Next, we're going to talk about drainage basins. All the precipitation that falls within a drainage basin flows into streams that drains that area. Stream drainage patterns are determined by the type of rock within that basin. Over geologic time, streams change the landscape that they flow within, and eventually they become graded, meaning their profile is a smooth curve. A stream can lose their gradation if there is renewed uplift or if their base level changes for some reason. Stream erosion and deposition. Erosion and deposition of particles within streams is primarily determined by the velocity of water. Erosion and deposition of different sized particles can happen at the same time. Some particles are moved along the bottom of a river, while some are suspended in the water itself. It takes a greater velocity of water to erode a particle from a stream bed than it does to keep it in suspension. Ions are also transported in solution. When a stream rises and occupies its floodplain, the velocity slows and natural levees form along the edges of the channel. Next time there's a big rain event in your area, try walking along a river, or maybe next spring or something like that, and you should see that there's probably some sedimentation or hills that are built up along a river. There was one event in my college town where almost like half the campus was flooded, and when we got back, our sedimentology teacher actually took us down to the park where we could actually see that there was sediment everywhere from the river. Stream types. Youthful streams in steep areas erode rapidly, and they tend to have steep, rocky, and relatively straight channels. Where sediment-rich streams empty into areas with lower gradients, braided streams can form. In areas with even lower gradients, and where silt and sand are the dominant sediments, meanders are common. Deltas form where streams flow into standing water. You'll find these where rivers empty into lakes, or into like the ocean, or into like the Gulf of Mexico. Think of the Louisiana Delta, like where the Mississippi River Delta. It's called a delta because it looks like a little triangle. It forms like a fan of sediment out there. Nile River Delta. There's different kinds of deltas, and I've actually gone over that in other videos, so I'll leave a little card for that for you to go check out. Flooding. Now, this book was written in Canada, so this next section may or may not be relevant to you. I live in Indiana, so it's not necessarily relevant to me. But this is what the book had to offer, so I will say it as is anyways. Most streams in Canada have their highest drainage rates in the spring and early summer, although many of British Columbia's coastal streams are highest in the winter. Floods happen when streams rise high enough to spill over its banks and spread across its floodplain. Some of the more significant floods in Canada include the Fraser River flood of 1948, the Saguenay River flood of 1996, the Red River flood of 1997, and the Alberta floods of 2013. I can think of, also in the United States, maybe whenever the Mississippi River floods, or whenever the Mississippi River floods. We can estimate the probability of a specific flood level based on the record of past floods, and we can take steps to minimize the impact of flooding by building man-made levees, like in Louisiana. Well, I hope you like my new spin on these videos, and keep an eye out. Hit the like and subscribe and all the bell stuff and all that jazz. Also, wherever you get your podcasts, go look up the Shistcast with me and Tyler Robinson. It's a hoot. Last time we watched Tremors and we reviewed it, and we got some good reviews on Twitter for it. With that, I bid you adieu and cheers.